On Nature League, we spend the third week of each month exploring a current trending article from the peer-reviewed literature. Scientific information isn't just for scientists, it's for everyone. It just requires a bit of a breakdown. For this month's Denatured segment, we're going to look at an article released online in January 2019 in the journal Biological Conservation. This month is all about extinction, and in this month's lesson plan, we discuss some traits that are connected to a higher likelihood of extinction. We mentioned how species with larger body sizes and ranges are typically more likely to go extinct from currently existing threats and pressures. But what about smaller organisms? What about the world's insects? Are they actually going extinct? In this paper entitled Worldwide Decline of the Entomofauna, a review of its drivers, the researchers investigated current trends and types of extinction threats to entomofauna, or insects, worldwide, and their results have stirred up some serious alarm. But first, let's discuss what's already known. It's estimated that about 1/5 of all vertebrates on Earth are threatened with extinction. These estimates come from decades of research on vertebrate species around the world. However, scientists have only recently started noting concerns about extinction risks to invertebrates, including insects. The main drivers of biodiversity loss at present are habitat loss and overexploitation. However, there's also evidence that the intensification of agriculture is the main driver of declines in smaller groups of taxa, like birds, insect-eating mammals, and insects. And it's not just the conversion of some habitat into agricultural lands, it's also the use of chemical fertilizers and pesticides that's driving some of the declines. In fact, 2 studies in 2013 pointed to pesticides as the primary driver of population declines of grassland birds and stream organisms. However, we don't know whether these factors are also connected to the global decline of insects being witnessed at present. Unfortunately, more and more research is providing evidence for a major and ongoing decline in insects worldwide. What's additionally troubling is that even though insects make up close to 2/3 of all land-dwelling species on Earth, most of the recent studies on insect declines weren't able to explain the majority of the declines. In this study, the team summarized all available research on insect declines worldwide and identified likely causes of these declines. They searched databases of peer-reviewed literature for any long-term insect surveys published within the last 40 years. They came up with 653 total publications, but filtered this list by removing studies that focused on individual species, outbreaks of pest species, and species considered invasive. Additional filtering related to study design and data types was implemented, resulting in a final total of 73 papers. The team used these papers to estimate the annual rate of decline for different groups of insects and regions of the world. Then, they counted and analyzed the reported drivers of these declines. So what'd they find? In this paper, the authors report their findings by taxa, or species groups, and by region. These details are available in the full article, but for the purposes of this episode, we're going to focus on overall trends and threats. Overall, the largest losses of insect biodiversity on land are in dung beetles in Mediterranean countries. Of these species, more than 60% are in decline, and a large proportion are considered threatened with extinction. Almost half of moth and butterfly species are declining more quickly than expected, and in bees, 1 in 6 species have gone regionally extinct. Overall, aquatic insects fared even worse than those on land. The research team also wanted to investigate what the drivers of these declines were, as stated in the papers they considered. Close to half of the studies included in their meta-analysis indicated that habitat loss and change were the main driver of insect declines, and the authors stressed that a lot of this is due to agriculture. In fact, 1/4 of their studies indicated that agriculture-related practices were the main driver of insect declines, both on land and in aquatic systems. The second main driver of reported insect declines was pollution, specifically in the form of fertilizers, synthetic pesticides, sewage and landfill components, and industrial chemicals from factories and mining operations. Other drivers included biological factors like parasites and pathogens, and climate change, which impacts abundance and distribution of many insect species. In conclusion, by compiling the results of published peer-reviewed articles, the authors estimate that the proportion of insect species in decline is 41%, and the pace of local extinctions is 10%. In the countries studied, the researchers estimate that about 1/3 of all insect species are threatened with extinction. This article is making major waves on social media and in the mainstream news media, which is rare for a journal article. Here's why I think the peer-reviewed piece is making the rounds. First off, we're sorta late to the insect game research-wise, despite them making up such a massive amount of life on Earth. So anytime a review article is published that catches us up on such a big piece of biodiversity, scientists and the public alike get excited. So that's the positive spin here, but you can probably guess what's coming next. The main reason I think this study went viral is because the news is bad. Like, really bad. To put it in perspective, the 41% of insects declining is double the proportion of decline in vertebrate species. And the local extinction rate of insects this study estimates is 8 times the local extinction rate of vertebrates. So perhaps a better question is, what's the big deal about losing insects? Most scientists will cite quite a few reasons, and most of these have to do with the services that insects provide for us and other species. These include pollination, food, nutrient cycling, and decomposition, among many others. What's more, the authors mentioned that because the declines in insects were documented in the majority of species across different groups of taxa, it is, in the authors' words, evident that we are witnessing the largest extinction event on Earth since the late Permian and Cretaceous periods. Cool. As with any piece of new research, there are several areas of improvement that exist in this study. This study was a meta-analysis. That means the researchers compiled and analyzed other research. So this study is subject to all of the uncertainties of the 73 papers included in their analysis. My issue is not with meta-analyses, but rather with data uncertainty. There's simply not enough information provided in the paper as presented to analyze the sources or extent of uncertainty in combining this many different measurements from so many different papers. Another issue I have with this meta-analysis is the inherent geographic bias in data availability. Long-term scientific surveys typically get funded and take place in developed countries, usually in the Northern Hemisphere. However, the authors directly acknowledge this and suggest that their review doesn't, in their words, adequately cover trends in tropical regions where information on insect biodiversity is either incomplete or lacking. And now for some real talk. One of my critiques here is more of a word of caution, particularly when discussing the results. There is a big difference between declining populations and extinct populations. Just because a population or species is declining does not mean it is or will go extinct. We have to be really careful to distinguish these two processes. The authors of this paper do a good job of making this distinction, but some reporting outlets have definitely confused the two. So let's be clear. This study used other studies to estimate that 41% of insect species are currently in decline. But these species are still here and still living, mutating, adapting, and evolving to the threats they're facing. While extinctions have and will continue to happen, life on Earth has proven itself to be a formidable contender. My last critique comes from ongoing research in both ecology and environmental philosophy, and it has to do with phrases and wording about ecosystems being pushed beyond the brink and collapsing. For example, in the conclusion section of the paper, the authors state that in terms of these current insect declines, the repercussions this will have for the planet's ecosystems are catastrophic, to say the least, as insects are at the structural and functional base of many of the world's ecosystems. Okay, so these are strong words, and the news outlets reporting on this study are using the same kind of collapse and catastrophe language. Don't get me wrong. If this report is accurate, I'm not happy about the results. I personally value having more species on Earth than less, but that value comes from a place of intrinsic worth and not some balance of nature ecosystem stability angle. The thing is, we don't really know what happens to ecosystems without insects. Perhaps this would result in other species going extinct, or perhaps other species would fill these functional roles and a different form of biodiversity would exist. There isn't some perfectly balanced ecosystem. This is completely relative to a pre-established idea of what balanced looks like. So my biggest critique here is a personal one. I wish we could discuss how much it sucks to lose species because of their own intrinsic worth instead of some human-conceived notion of the balance of nature. My personal take-home message? Insects are incredible in their own right, and our actions are negatively impacting them in ways that could lead to some extinctions. Thanks for watching this episode of Denatured here on Nature League. We'll be shooting a question and answer episode soon, and we'd love to hear from you. If you have a question related to life on Earth, leave it in the comments below, or tweet me at Nature League, and your question could be featured in the next Q&A video. And to keep going on Life on Earth adventures with us each week, make sure to subscribe at youtube.com/natureleague and share.